Good afternoon, everyone. My name is Jessica Kavina, and I will be the course moderator for today's meeting. Welcome to Net Zero for Government Buildings, Going Beyond the Executive Orders. Now let me introduce today's presenter. Dave Pratt is a professional mechanical engineer in the state of Texas, a certified energy manager, and lead AP. He has a Bachelor of Science in Engineering from the University of Michigan and a Master of Science in Engineering Management from the Air Force Institute of Technology. Dave has over 12 years of experience in civil and mechanical engineering, construction and sustainable design, and is a frequent contributor to the Green Building Research Institute. Thank you so much for joining us today. Here is Dave Pratt.
NetZero buildings are also known as zero energy buildings, zero net energy buildings, and net zero energy buildings. The definition of a net zero energy building, according to the New Buildings Institute, is a building that uses no more energy over the course of the year than they produce from on-site renewable sources. Torsolini and Pless defined a net zero building in the paper Getting to Net Zero as a building where the use of on-site renewable options over off-site options minimizes the overall environmental impact of a net zero energy building by reducing energy transportation, transmission, and conversion losses. Conceptually, a net zero energy building is one that has no adverse energy or environmental impact associated with its operation. So James Tomas, an associate at GluMac, which is a mechanical, electrical, plumbing consulting firm, wrote an article on net zero buildings, which I'll summarize here. In perhaps the most comprehensive study of the potential for net zero energy commercial buildings conducted by the National Renewable Energy Lab, or NREL, only a small portion of the existing variety of commercial buildings were judged to be good candidates to become net zero buildings. They found that the best candidates are low-rise 1- and 2-story buildings, which help provide enough roof area to install the amount of solar photovoltaic panels required to reach net zero. Also, buildings with inherently low plug and process energy needs are very good candidates. The best candidates in order of potential are unrefrigerated warehouses, churches, retail, schools, public assemblies, outpatient healthcare, and some professional offices. Conversely, the buildings with the least promising as net zero energy candidates are those with high plug and process loads, such as hospitals, laboratories, skilled nursing, restaurants, and refrigerated warehouses. Section 4, Building Certification. The Net Zero Energy Building Certification is a program operated by the International Living Future Institute using the structure of the Living Building Challenge. The Net Zero Energy Building Certification verifies that a building is truly operating as claimed, harnessing energy from the sun, wind, or earth to exceed net annual demand. It provides a platform for the building to inform other efforts throughout the world and accelerate the implementation of the restorative principles. This project was to build a 72,000 square foot elementary school, including a gym and cafeteria in Richardsville, Kentucky, which is just north of Bowling Green. The school was to hold 460 students and 35 staff members. The project has the distinction of being the very first net zero energy school in the United States and has won numerous awards. The Warren County Public School District in South Central Kentucky has a long history of energy management, being one of the first school districts in the state to hire a full-time energy manager. The school district had 5 Energy Star schools when Plano Elementary opened in 2007. And Plano Elementary had an Energy Star rating of 99 and an annual energy use intensity of 26.8 kBTU per square foot. However, a photovoltaic system with enough capacity to produce Plano's 26.8 kilobTUs per square foot per year was too expensive for Warren County's construction budget. Therefore, the team designated a new energy use intensity target of 17 kBTU per square foot per year, as a basis for a financial model that indicated a 15-year simple return on investment.